So if I could just get a thumbs up from the lectern there that you can hear me okay?
Kathy, could you please test that we can hear you?
Yep, can you hear me? If you can hear me,
Okay, so I think people can hear me, but I believe here in this room we cannot hear Kathy. Oh, it seems that they can hear her online. So 1 second while we solve this.
sure, no problem. So we have for people who are on Zoom, we have a lovely phrase in Australian English called "no worries." Was that right? Did you guys saying something?
Okay, Kathy, could you try again speaking?
Sure thing. This is a test. Yep. So you're on mute. If you could give me a thumbs up that you can hear me in the room. Wonderful. Okay, I'll begin. Thank you so much, everyone, for your patience there. So I'm Kathy Reid. I'm from Australian National University's School of Cybernetics, and I'm speaking to the paper Common Voice and Accent Choice, which is joint work with my doctoral supervisor, Dr. Elizabeth T. Williams. We're motivated here by the rapid adoption of machine learning-based speech technologies like speech recognition, voice assistants, and automated captions. And it's well established that these systems don't work well for everyone. Well, at least not yet. And in particular, they don't work well for people who speak with some accents. Here, we explore how accents are represented in voice data and what we can learn from how people describe their own accents. First, we explore the concept of accent and how accents are represented in voice data. Everyone who speaks with an accent. You can tell I'm Australian by the way I speak. My A sounds veer towards R sounds. I say vase to rhyme with Mars, not vase to rhyme with face. So an accent can be viewed from a linguistic perspective. But my accent is also a social category, a marker of similarity or difference. Here in Australia, my accent is normal or standard, but if I were with you in Boston, it would be distinct or unusual. It would be a marked category. People who speak with non-standard accents often experience stereotyping and prejudice, unequal treatment. We term this phenomenon accent bias. As speech becomes datafied, turned into data for machine learning, accent bias becomes automated and accelerated because it becomes easier to sort speakers into categories based on their accent. For example, this person speaks English with a Latino accent, or this person speaks with a Southern drawl. Automated accent bias has its roots in voice data. Voice data are the sounds we speak and the words they represent. And this is an example of voice data from Mozilla's Common Voice dataset. You can see the audio file and the words that the audio corresponds to. Voice data may also include metadata, which describes the characteristics of the speaker and the language they're speaking, including their accent. And here the accent is described as Australian English using our text string. But the accent could also be described using one of several standards for representing languages. For example, the ISO 639 standard doesn't distinguish between varieties of English spoken in different regions, And we'd have to represent Australian English using just the code for English. BCP 47, however, allows us to distinguish English spoken in different regions, but even this masks differences within a particular region. Consider, for example, the large variations in accent in Great Britain or the United States. A Boston accent sounds very different from a Valley accent. So existing standards don't represent the nuance or variation in spoken accents very well. And this led to our first research question. How are accents currently represented in voice datasets? Do they use standards like BCP 47 or ISO 639? And the short answer is generally no. None of the 13 open source datasets we investigated used a language standard like ISO 639 or BCP 47 to represent accent. We can't be sure about the commercial datasets because they're proprietary. This presents problems with commensurability. In machine learning, many datasets are often combined to train a model. But how do you combine voice data with particular accents if you don't have shared ways to represent those accents? From this finding, we then wondered how people describe their own accents, as this may provide evidence for changing how accents are represented in voice data. Here we draw from the work of Jeff Barker and Susan Lee Starr, and their work in categorization, in particular their distinction between formal and practical classification. Formal classification is standardized through processes of politics and power, and it's often difficult to change. By contrast, practical classification is often used by lay people to deal with the messiness of real-life situations. And so while linguists perform formal classification of accents, we wondered, how would lay people describe their own accents? To answer this question, we analysed self-described accents from Mozilla's Common Voice English dataset. This dataset represents the only currently available source of self-described accent data for English, and it's also the largest open source voice dataset in the world. I won't go into detail about the data engineering here, that's all covered in our paper, but in summary, we filtered nearly 1 million rows of data and over 15,000 accent descriptors down into 235 distinct accents. We then coded the 235 accents and a taxonomy emerged, which is visualized here. Don't look too hard at this. I'm going to step through it. We can see that the vast majority of self-described accents are still predominantly geographical. However, what's interesting here is that the accents don't just use a country or national descriptor, which is what BCP 47 typically uses, the ENAU code or the ENUS code. The largest category here are accents that were described using a subnational region, such as the Midwestern United States, or Texas, or Southern India, or the English Midlands. Supranational regions that cover more than one country were also used as descriptors. For example, several people use the term European or Eastern European to describe their accent, although we note they generally used another accent descriptor as well, such as French or Polish. Geographical categories have both linguistic and social identity elements. For example, if you speak with a Boston accent, a city category, you have both linguistic changes, park your car in Harvard Yard, and you may also have a social identity as a Bostonian. But what about the other categories we identified in this taxonomy? If we move away from geographical descriptors, then the next most frequently used categories were first or other language markers, such as non-native speaker, and descriptors indicating the strength of a person's accent, such as I speak with a little bit of an accent or a bit of an accent. We found that people were more likely to use descriptors that mark their accent as non-standard, such as speaking English as a second language, than they were to use descriptors for a standard accent, such as native speaker. People also tended to downplay the strength of their accent, so even though accents were frequently described as non-standard or marked, how marked they were was downplayed. So these categories focus on linguistic differences, particularly marked or differentiated ways of speaking. Another interesting category was the use of specifically named accents as descriptors, such as Okie or Valley Girl, or for anyone who's familiar with New Zealand Aotearoa, Kiwi. This tracks with accent as a social category, people identified with the social group created by that named accent. And we note here that the social group may not be tied to a geographical area. For example, people who identify with the Okie accent may have migrated to other parts of the United States in the Depression era. We then visualize the relationships between accent descriptors by linking accent descriptors that are expressed together, for example, Midwestern United States and Minnesotan. Don't worry too much about trying to read the graph. It's a bit small to see, and again, I'll step through it. We originally visualized all 235 accents and 515 links between accents, but we found that this visualization was too busy to be meaningful. It's linked from our paper if you're curious. So we did additional work to be able to filter by a particular accent descriptor. And here we can see all of the descriptors that were expressed together with the England English descriptor. The size of the nodes is proportional to the number of data contributors who express their accent using that descriptor. So here the large yellow node to the right is United States English, and the orange node to the bottom is Indian and Sri Lankan English. Both of these descriptors were predetermined accents available in Common Voice prior to 2022, so they occur a lot more frequently in the data. Also here on the top left of the diagram, you can see many of the sub-national geographic descriptors, regional geographic descriptors that were used to describe accents from Great Britain, all of the accents that are glossed over with the ENGB code from BCP 47. The key point here is that people will often use multiple granular descriptions to express their accent, and we can start to explore their relationships by visualizing them. We then decided to see whether the taxonomy that had previously been identified could be applied beyond English. And we chose Kiswahili here because, like English, it's also known to have a lot of variance in how it's spoken in different regions, and habari to anyone who speaks Swahili. We repeated the process we had applied for English to the Common Voice Kiswahili dataset and visualized it in the same way. Our key test here was whether we needed to create any new categories in the taxonomy to account for all the accent descriptors in Kiswahili, and we didn't. I do have to note here that the Kiswahili dataset and the number of data contributors was much smaller than English, but this was some early evidence of the applicability of the taxonomy beyond English. So what does this all mean? And there are a number of limitations with our work here, and we detail these in our paper. But that said, this work provides some early evidence for rethinking how we represent spoken language in voice datasets. The existing standards we have at our disposal, which aren't widely used, are insufficient for labeling accents in voice data, which we need if we want to make models work better for particular accents. To address this, we consider extending the BCP 47 standard. However, we note here the double-edged sword of granular accent data. On one hand, if we have more granular accent metadata, it allows us to tailor machine learning models to specific accents, but it also allows us to better distinguish between speakers of specific accents. It can make it easier to automate accent bias. In conclusion, we examined how accent data is represented in voice datasets, and in particular how data contributors, lay people, self-describe their accents. We produced a taxonomy of those accent descriptors and demonstrated the taxonomy was applicable to a language other than English, Kiswahili. And this work provides evidence to rethink how we represent spoken accents in voice datasets so we can build speech technology that works better for more people. Thank you very much, and I warmly invite your questions.